Hi, I'm Ryan Nickel, CTO at DSA Ocean. And today I want to talk about simulation of a mooring recovery in ProteusDS Oceanographic. So we're going to work with the SOFS 5 template mooring. You can see the file open in Designer already here. This is a full ocean depth surface mooring in almost 5,000 meters of water depth. There's a current profile already configured for it. And the first thing we want to do is start with a static profile. We can do that with ProteusDS Simulation Toolbox under Static Export. But actually, I've already got that set up. Look under Mooring Recovery and Static. So you can see I've got some results here already. Let's take a quick peek at what they look like, just to refresh our memories. So I'm going to change in PostPDS to engineering view. There's already a tutorial that goes through this in detail on the steps to look at this analysis process. So this is just a refresher. So there's the initial conditions, a straight line. This is roughly what it looks like in calm conditions. And then there's the deflected mooring with the current profile that we configured. Actually, you can see this little tiny jog down here is where the acoustic release assembly is. So there's lots of glass floats there maintaining some tension and to assist in recovery. That's what we want to take a closer look at, what that process looks like. So close this. We're only going to work in Proteus Simulation Toolbox right now. So what we want to do is use that deflected profile as the starting point for the recovery. So we'll click on Export now. And I'm going to make a new folder called Recovery Analysis. Open this new project. So I've got there's another folder in here already. I'll just delete that. This recovery analysis folder, those are the project files for Proteus Simulation Toolbox. There's a couple things we need to do to get this ready to go. We don't need the static profile anymore. So project. So first thing we want to do is change quasi-static cable to a dynamic object. So we'll go convert the object, quasi-static cable to cable. So this allows us to model the full dynamics of the transient motion of the mooring released from the seabed. Go OK. Want to double check that the anchor is turned off. By default, it is off. We've got our X-mass cylinder generic anchor. Yeah, it's commented out here, so it's not going to be weighing down the end of the anchor there. The other thing we need to do is unpin the node N value from the seabed. So we'll just set that to 0 there. And the last thing we need to do is make sure we have a long enough simulation. So sometimes it can take a while for the acoustic release assembly to come to the surface. And if you're not sure, you can do a bit of short simulations to trial and error and help guess when it might come up to the surface. But the other thing you can do is just run a longer simulation. So I'm going to run this one. It's probably far longer than it really needs to be. But I'm just going to run it overnight and see what happens. So interval output, 5 seconds. We don't really need a lot of high resolution data. Again, it moves kind of slow depending on how far it is from the surface and that sort of thing. But yeah, printing out files every 5 seconds I think is fine. So yeah, so we'll save it and then run it. All right, so sometime later, I didn't let it finish all the way, but I took a peek at what it was doing post-PDS to see what was happening in the simulation. So we'll open this up. And so, again, sometimes this can take a long time to load because there can be a lot of data. I'm going to specify a zone skip, just saying it's going to skip every 10th and load only every 10th data step, and it should load much faster. Because I just want to take a peek and see what's going on right now. So we'll go to engineering view and east view. Again, remember the current profile is still on, so there should be some drift. And now there's no anchor on the bottom, and the node on the bottom here is not constrained, so we should see it floating up to the surface. And there you can see it looks a little jerky because, again, I've only loaded part of the data, and we're also printing out every 5 seconds. There we go. So it's reached the surface. a few hundred seconds, so it didn't take too long to get to the surface actually compared to the simulation length. And you can see it starts to drift there along the surface as the rest of the mooring pulls up. And we're expecting to see this drift. That's from the current profile. So in any case, wanted to show how to set that up in ProteusDS and ProteusDS Oceanographic. And that's all for now. Thanks for watching.